This is a discussion of the Reliable Data Transfer Lab. We have here the Go Backend code up. You can look at first. Well, first let's run a couple of scenarios. I'm going to start with debugging. So let's just simulate 3 messages. No loss probability, no corruption probability. We'll do 50 time between messages and trace level 3. So here you can see it's generating the first thing. It's generated, it starts at time 4.6. The data given is AAA, whatever. You can see the checksum implemented right here. It's 1940 is the checksum for the A series. Then you can see that here at time 10 point whatever, the data is received to AAA. The packet checksum was equivalent, it was 1940, so it returned the data correctly, and it acknowledged it. And you can see at the future time, this packet will be delivered at 12, and at the time 12 it's delivered and the timer is stopped. So now the next event occurs at 80, and it's the second sequence number, and you can see the checksum for it comes out to be 1960, and it's the series of B's. And so you see here at time 81, the data is received at the B, and it's a bunch of series of B's, and it's going to return it. And so it does, it's successful, and it stops the timer at time 87. Then finally we have the third packet. It's once same thing, checksum 1980, series of C's. It's going to deliver then, and then at that time it simulator terminates after it finishes sending the third message. Now let's show the code running with some other scenarios. So let's put it again, 3 messages. Let's simulate a 0.5 chance of packet loss, no corruption, 50 seconds between messages, and trace level 3 again. Now this one we should have a half chance of loss, so there should be some lost packets. You can see this first one, the A is scheduled correct on layer 3, scheduled arrival correctly, so it's going to arrive at the next layer. So it does, you see it arrives, the data is received, however the response is supposed to be lost, which it is, so it schedules this time for the timeout to be at 44. So we have timer interrupt, and it keeps timing out, so then the packet's continuously lost on the resend, so we get to the point where B is to be sent, so it sends B, and you can see B is going to be lost too. So now since I put in a high probability of loss, we're losing a lot of packets. You can see it's lost again. But okay, here we go. This time one on the resend B was received, however the response was lost, so that should make it have to resend B, and you can see it does. It attempts to resend B, and this time it's going to be successful. It's resending A and resending B, but this time B is going to be successful, and there it is. And then it has to send C, and then once it sends C, the program times out. But you can see that each time a packet is lost, it resends that packet and the previous packet before. For example, right on one of these you could see that it's resending it multiple times. Now let's debug and do it with corruption. So we have 3 loss probability, let's say 0 loss probability this time, and let's say 0.5 corruption probability. We'll do time 50, and we'll do trace 3 again. Now this time we should have a lot of corruption, but that will be okay. So you can see it's sending A, and it's going to arrive successfully for this one, so this send was not corrupted. So the checksum was 1940, it received it. The checksum was also 1940. It received the data, so it's going to respond with corrupted packets, and so the timer stops. Oh, actually, wait. Okay, now I got this problem I had fixed. Let's see what it does for corruption again. Okay, let's try this again. Let's do 3. Probability of loss, 0. Probability of corruption, we'll do 0.5 again. Time between messages, 50. Trace level 3. Now, you can see this time it's scheduled for arrival, and it arrives at the second layer, or well, layer 5. And then this time it's being corrupted on the return, so it attempts to start. It doesn't stop the timer, it attempts to restart it, so we get some timeouts this time until it repeatedly times out because of the 0.5 thing. But then we have B, and it starts a timer, and it schedules, well, it's corrupted, and so it does the same thing. It's incorrect, so it tries to resend B. Data received is B, and then it works correctly the second time. You can see here it works correctly, so it receives it and it stops the timer. And then with C, once it sends, the program exits. Okay, now with the execution of the programs shown, I'll show you the code that was written. We start off from the top. We have all the defines, the structure creation, the creation of the structure packet, all the function prototypes, and then have some variables declared, including the timeout, which is 20 seconds. You saw in the execution that each time it timed out, it would take 20 seconds before it tried to resend, and the amount of packets that can be used. The initialization of A is here. It declares the base to 1 and the next sequence number to 1. So this is where it starts, and you can see here we have output for A, and it takes the message in. And so if the next sequence number is less than the base plus GN, and what GN is 3, I believe, is the, you can see GN is 3, so the window, the sliding window for the go back in is going to be 3. So as long as it's less than the whatever number you're on, the base, plus 3. So base starts at 1, so if it's less than 4, it's going to do the output. Now we have this. GSend packet is a variable. It's the packet that's going to be sent. So the GSend packet and the sequence number, and this is the sequence number that's going to connect. So GSend packet and whatever thing you're on, and dot sequence number. So the sequence number inside of packet, which is right here, you can see, is going to be set to the next sequence number. Then here we set the payload, so a loop through 20 times, set the packet of next sequence number, so the packet you're working on, dot payload of whatever iteration we're on in the loop is equal to message.data and whatever iteration. So it's setting the payload of GSend packet to message data. And then third, we have the checksum. So once again, for a loop, this packet is equal to the original checksum, which is nothing, plus the payload, plus the ACK number, which is to make sure that nothing gets corrupted. Then it's this is the actual send statement to layer 3, and it's sending from A, and it's sending the packet that was just changed. And then if the base is equal to the next sequence number, start the timer, and then bring this next sequence number up 1. Then we have the timer interrupt. This is just if a timer is interrupted, it starts the timer and then resends. So if the timer times out, so if it goes past how long it's supposed to be, it's just going to resend whatever packet you're on. and all the next sequence number. So it will send from the base to the sequence number that was supposed to be sent last. So it will resend the last group of packets that are in the window. Then we have input. So this is the input. It takes packet, type packet, and it's called the variable packet. So gbase is equal to the acknowledgement number plus 1. I created a temporary variable which is initialized to 0, and then it's declared to be equal to the checksum that you receive, so the packet checksum, and then I have a statement for debugging. And then declare the checksum to be 0, and then loop through 20 times, set the checksum to the payload, so it's the sum of the payloads. And then if it's this next sequence number and the checksum is equal, then stop the timer, otherwise start the timer, and this will cause a timeout. Or it will let the program know that the message was not received correctly, so therefore a timeout will occur and the message will, the packets will be resent, and then outputs. Then here's the other side of all the code for the other side. We have the expected sequence number and the structure acknowledgement packet, ACK-pack. It's initialized to have the sequence number to be, the expected sequence number is 1, is how it starts, and the acknowledgement number for ACK-pack is going to be the expected sequence number. Oops, sorry. Jump down. Okay. Then the input, we have B input, and it's once again the type packet, structure packet, and it's variable packet. And so the checksum for the packet starts at 0, loop through 20 times, the checksum is equal to checksum plus payload, so all the payloads sum together, and then an output statement to check what it is. Then the ACK-pack checksum is 0, and set the this sets the ACK-pack payloads to the received payloads. So ACK-packs, all the payload of ACK-pack is going to be the payload of the packet, and then the checksum for ACK-pack is equal to the summation of the ACK-pack payloads, and then an output statement to debug. And then if the sequence number is equal to the expected sequence number, and the checksum is equal to the correct checksum, then send to layer 5 the payload, send the acknowledgement number is equal to the sequence number, and then send to layer 3 from B, send ACK-pack, and then increase the sequence number, and then there's timer interrupt, and then that's all of the code for the things that we had to do. Down below is all the code that was given. This was not supposed to be changed. That's all of the code.